Hi guys. Okay, so we are going to cover chapter 4, learning check problems from the Open Stax book on chemistry. And in this video, we will cover 4.1 to 4.4, which relates to balancing equations, ionic and net ionic equation, precipitation, and the acid-base reactions. So to solve these problems, you would be needing access to the tables. In all ideal respect, you need to memorize. Okay, you need to memorize the symbols of the elements, you need to know the charges, you need to know their placement in the periodic table, you need to know the polyatomic ions and their charges. If you know the elements that can make more than one type of positive charge, then that's great, right? And then also the solubility rules. Okay, if not, or let's say you forget, so you do have access to these in your handout, in your book. There are tables. So the most important thing is at least you should know which table to use and how to access that information and how to reference those. But in general, let's look at these general trends in the periodic tables, so it's kind of a review. Now, I have already made the videos on the nomenclature where you will see this same table, and I have explained a lot of those things in details over there. I have also made the videos on the single displacement, double displacement reaction, solubility rules, where I'm covering, explanations in detail, and there are some practice problems also. So feel free to look at those, first study those, because this is just learning check problems from the book. And so we will be just, doing a big overview of what we know from these tables. Okay, so here, another thing is, since I could only put so much information in one page, you need to take your own notes and add more information from these specific tables also in your own notes. Okay, so let's just do a review now. So here you are aware that when we look at the groups, okay, the group number relates to the valence electrons, and these valence electrons pertain to how many bonds an atom can make, and it relates to the charges. Okay, +1 charge when the electrons are given, -1 charge is when the when the electrons are taken, and depends how many electrons are given and taken, that defines how many charges. Okay, so group 1A, 1 valence electron +1 charge. Group 2A, 2 valence electrons +2 charge. 3A, 3 valence electrons +3 charge. 4A has 4 valence electrons, can make 4, +4 can make -4. So, and it can also form sharing. So it's so +4 and -4 charges are because of the transfer of the electrons, but sharing of the electrons is not going to lead to any charges. Okay, next is group 5A. Now that's a little bit opposite. Group 5A, there are 5 valence electrons, and so the main general rule of how many electrons are given or lost is satisfying the octet, that is the 8 electrons in the last shell. So if there are 5 electrons already, it's not energetically efficient to lose 5 electrons. So that is why gaining electrons is more feasible. So group 5A elements, all of them will, or not all, because there are metalloids also and semi-metals, in other words. So but anyway, the non-metals, these will make -3 charge. Okay, so that's 3 bonds. Group 6A, 6 valence electrons, -2 charge, and will only make 2 bonds. 7A, 7 valence electrons, -1 charge, and 8A, 8 valence electrons, and no charges. So depending upon if 3 charges, 3 bonds, 2 charges, 2 bonds, 1 charge, 1 bond, and no charge, no bond. Okay, so that's one piece right here. Next is which of these elements can form, we already discussed that, how many charges. Next is the polyatomic ions. So these are some of the non-metals, they combine with with each other or with oxygen, and then they retain a charge. So again, you need to take your own notes. Best is to memorize them, but just so you know now that 8 refers to a higher oxidation state, and 8 refers to a lower oxidation state. 8 means less oxygens and 8 is more oxygens, but this relates to with every single element. So in nitrogen can combine with 2 oxygen, and nitrogen can combine with 3 oxygens. So nitrate And nitrite. Nitrite is with 2 oxygens. Nitrate is with 3 oxygens, and each will have a -1 charge. Sulfite and sulfate, on the other hand, now sulfite, just because there are 3 oxygens, but you also have to see what is the other elements that the 3 oxygens are combining with. That's sulfur. So here you have sulfur combining with 3 oxygens is sulfide, but sulfur has a capacity to combine with more than 3 oxygens also. So with sulfate, sulfate -2 charge, okay? So SO4 -2 charge. And SO4 -2 charge is sulfate, and SO3 -2 charge is sulfide. Then same is the case with phosphate and phosphide. And we already covered this in the nomenclature video about the chlorate, perchlorate, hypochlorate, and hypochlorite, but look at those videos, okay? Next is the hydroxide, bicarbonate, bisulfate, biphosphate, permanganate, dichromate, bromate. So these are just some I have written. If there are more, please do write more of those. Okay, then the solubility rules. So we discussed again in one of the videos the solubility rules in great details, and there's some practice problems also. So look at that video. But here we are just doing the applications of all these. So you have we know that in group 1A, anytime group 1A combines with any other anion, those ions are going to make the compound soluble. So anytime something is soluble, we write down AQ, okay? That means it dissolves in water, okay? Next is ammonium. Anytime ammonium attaches to anything, soluble in water. Nitrate attaches to something, soluble in water. Acetate attaches to something, soluble in water. Bicarbonate, soluble in water. Chlorates, soluble in water. Now halides are chloride, bromides, iodides are all soluble in water except silver chloride and PbCl2, that's lead +2 state. So anything when it is not solid or in a precipitate, right, that is a solid, right? So it is written as S. So don't confuse S with solubility. S stands for that exceptions where the compound will not dissolve in water. That means it will not ionize, okay? So silver chloride, bromide and iodide, similarly lead, chloride, bromide and iodide in +2 state will not dissolve. Sulfates, all the sulfates are soluble in water except calcium sulfate, barium sulfate, strontium sulfate, lead sulfate and silver sulfate. Now, all the ones that are insolubles are carbonate, phosphate, sulfide, and chromate, except to group 1A and ammonium. So when group 1A and ammonium combines with anything, no matter if it's phosphate, if it's carbonate, sulfide, or chromate, soluble in water, okay? Next is the only exception to the hydroxides. All the hydroxides are insoluble, except barium hydroxide and all the elements that are in group 1A, if they connect with hydroxide, and ammonium, if that connects with hydroxide, it will be soluble. So, okay, so this was a brief overview of all the tables that you would be needing for this section. Now let's look at this problem, a learning check problem on page 179, 4.1. So here we're talking about the decomposition of, this is a decomposition reaction, and in a decomposition reaction, let's do this. This is a decomposition reaction. In a decomposition reaction, ammonium nitrate is breaking up into molecular nitrogen, molecular oxygen, and water, okay? So they're asking you to balance the equation. Now, in general, when you see the oxygen is now, first initially it was with nitrate, but now it has split up and it has gone into 2 different species, molecular oxygen and water. So that means there is a general rule that you need to follow. And that rule is always first balance the nitrogen, or if you're looking at carbon, you first balance the carbon. Then you balance, secondly, is the hydrogen. Last, you balance the oxygen. Now, sometimes it's oxygen is odd on one side and it's even on the other side. And then what do? Then you multiply all the other species, with 2, except for oxygen. Hold on to oxygen. Okay, and then you last look at the oxygen and you balance oxygen last. Okay, so let's do this problem first. First, whenever we balance, as you are already aware, that we are going to write down what are the initial, like individual components or the individual atoms in this. So we see one nitrogen and one nitrogen. So there are two nitrogens, there are four hydrogens, and there are three oxygens. Okay, here we have two nitrogens, we have two oxygens, and we have two hydrogens, and we have one more oxygen. So a total of three oxygens. Okay, I'm going to just put it like that. Okay, three oxygens. So now what do you see here? We see that two nitrogens and two nitrogens are balanced. So we are good with that. 2 and 2 balanced. Okay. Hydrogen is not balanced. Hydrogen is 2 on one side and is 4 on the other side. So what do? You're going to put 2 here. So this 2 applies to hydrogen, but this 2 also applies to oxygen. So what happens to hydrogen now? Hydrogen multiplied by 2 becomes, like here is 4 hydrogens, and oxygen, 1 oxygen times 2 becomes 2 oxygens. Okay, so 2 oxygens. So now that changes. Now the oxygens have changed. So now what do we see here? Let's look at this first: hydrogens, 4 hydrogens and 4 hydrogens. So nitrogens got balanced, hydrogens got balanced. The only thing that is not balanced now is oxygen. There are 3 oxygens this side, and a total of 2 plus 2 is equal to 4 oxygens now on the other side. So in this case, we have 3 here, odd number, 4 here, even number. So what are you going to do? You are going to multiply all the other species with 2, and you're going to leave the hydrogen, leave the oxygen, sorry, leave oxygen. So let's do this first here. Multiply all the other species with 2. Okay, so let's do this again. We are writing this now. See this here. Here, okay. So this is our equation, and now we are going to take this multiply. So this is going to be now step 1. This becomes step 1, and here becomes step 2. Okay, step 2. So here I'm going to do in step 2. All right, so in step 2, this guy is going to be multiplied by 2. This one is going to be multiplied by 2. This one, you hold on, wait, okay? Hold on, do not multiply by 2. But this one is going to be multiplied by 2. So what do you get here now? You have 2NH4NO3. You multiplied by 2, right? And here becomes 2N2. Okay. Oxygen is holding on, plus 2 times 2, 4H2O. So now what do you get here? You have now 2 times 2. So this becomes 4 nitrogens. There were initially 2 nitrogens, remember? So, but now with 2, it becomes 4 nitrogens. So this 2 is going to apply to nitrogen, this 2 applies to hydrogen, this 2 applies to this nitrogen also, and this applies to this oxygen. This applies to this nitrogen, this 4 applies to hydrogen, and 4 applies to oxygen. So that's why 4 nitrogens, 2 4s are 8 hydrogens, 2 3s are 6 oxygens. Okay, here you have 4 nitrogens, and 4 2s are 8 hydrogens. So there are 2 oxygens still here, and there are 4 oxygens still here. Okay, so now let's see this. 4 nitrogens balanced, 8 hydrogens balanced. Okay, now here you have to combine this 2 plus 4. What do you get? 2 plus 4 is equal to 6 oxygens. Okay, and there are 6 oxygens here. So oxygen and oxygen also balanced. So this only happens if you see oxygen splitting up into more than two species, and then you have to follow this step. Okay, so that was our 4.1. Next, let's look at the 4.2. Okay, so 4.2, page 182. Here you have a solution of brine. Now, brine solution is when sodium hydroxide is added, when sodium chloride, when sodium chloride that is your common salt, table salt, is added to water. Okay, so that's called a brine solution. Anyway, so here you have a brine solution in which you pass electrical current, and you see that it splits up. It gives you sodium hydroxide, hydrogen gas, and chlorine gas. So now the question is that what is the molecular equation? Molecular equation is what you have written right now, what you see, but we have to make sure that it is balanced. So always, always, always check for balancing the equations. Okay, so let's write down a balanced equation. Okay, so I have removed the solubility, like the subscripts, which is the aqueous and the liquids and the gas, those things, because we just want to focus on balancing first. So, and it's a matter of space. So here we have one sodium, and we have one chlorine, and we have two hydrogens, and we have one oxygen. Okay, this gives you, this is here one sodium from the hydroxide, and there is one oxygen, there is one hydrogen, and here you have two hydrogens, and you have two chlorines. Okay, so here, what do? We are going to add, because see what is not balanced. Two chlorines here, one chlorine here, obviously not balanced. And if you look at the hydrogens also, hydrogens are two here, but hydrogen is 2 plus 1, 3 hydrogens, so not balanced. So let's balance the chlorine first. Chlorine's 2 and here. So that makes now sodium, changes sodium and it changes the chlorine. So now you have 2 sodiums and you have 2 chlorines. Okay, so now chlorines are gone, chlorines are balanced. Sorry, this is chlorines are balanced, but now we are going to look at the balancing of sodium. So you will add 2 here. This 2 applies to sodium. This 2 applies to oxygen. This coefficient of 2 applies to hydrogen. Just like this changed the sodium and the chlorine. Similarly, this sodium times 2, oxygen times 2, hydrogen times 2 gives you 2 sodiums, 2 oxygens, and 2 hydrogens. Okay, so now you see 2 sodiums are on both the sides, so sodiums are balanced. But let's see now, hydrogens are 2 on this side, and there are 2 hydrogens here, but now we have 2 hydrogens here. So how many hydrogens are there now? We have a total of 4 hydrogens on one side, and so we need to put 2 here. So we have 4 hydrogens here. Okay, so 2 times hydrogen and 2 times oxygen. So now that changes the oxygen also. So we have 4 hydrogens on the left-hand side and 2 oxygens on the left-hand side. So a total of, let us see, now we have the hydrogens are 4 and hydrogens are 4 on both the sides. Then oxygens are 2 and the oxygens are 2. So 2 oxygens, 2 oxygens. Let's change this. 2 oxygens, 2 sodiums, 2 sodiums. And we have 2 chlorines and 2 chlorines. Okay. And then hydrogen is 4 hydrogens here and 2 plus 2, 4 hydrogens. Okay, so this balances this equation. So we see now that the coefficient of 2 actually applies to every single element that is in that compound or molecule. Okay, all right, now that's one question, write the balanced equation. Next is, they are saying, write the total ionic equation. Okay, so total ionic means you are going to ionize the species, so ionize species that are soluble in water, okay? Soluble in water only, soluble in water. That's one thing. Next is, this is a rule, do not ionize what? Do not ionize the precipitate, okay? Precipitate is the solid, okay? Next is liquids, something that is clearly a liquid, that is like water and is L, and something that is gas, this is written as G. Okay, so these do not dissolve in water. These guys do not, they do not. So in other words, the species that are solids, liquids, or gases do not dissolve in water. And even if they do dissolve in water, like let's say gases, but the moment the pressure and the temperature changes, they can leave. Okay, so that's why they may be temporarily insoluble. Okay, so that's one thing. Okay, anyway, so let's look at now, we are looking at sodium chloride. Now let's once again write down the solubility. All chlorides are soluble in water. And sodium is group 1A. So this is definitely going to dissolve in water. Okay, so that's one piece. Next is water itself is acting as a solution, right? So, and water in a liquid state. So 2 and 2 H2O. Okay, and that is in a liquid state, liquid. So that is not going to dissolve in water. Okay, so I mean, it is just water, it's a solvent. So liquid. Next is, this is giving you 2 moles of NaOH. NaOH, all hydroxides are insoluble except group 1A, and sodium is in group 1A. So this is aqueous. Okay, so at this point, I highly encourage you to look at my other video on solubility, in which I have gone in more detail on specific, species that are soluble or insoluble in water. So you can get practice from there. Okay, anyway, so now we have hydrogen as a gas, which will not ionize, and we have chlorine as a gas, which is not going to ionize. Okay, so now we are going to write 2 of Na. Na is in group 1A. So the charge is +1. Now you can +1 or 1 minus, 1 plus is the same. But this is soluble in water, so put Aq. Plus 2 of chlorines. Minus 1 aqueous. Okay, plus 2H2O, do not ionize that, 2H2O liquid. This gives you 2 Na, group 1A, plus 1 charge, aqueous, soluble in water, and the hydroxide ion, because hydroxide is coming from sodium. And sodium is releasing that hydroxide. Hydroxide is a -1 charge, aqueous, okay, plus hydrogen gas is not going to ionize, so remain it as a gas, and Cl2 is a gas, it will not ionize, okay? So now, here's the thing, important, spectator ions. Which ones are the spectator ions and which ones are the other ions? So spectator, T-A-T-O-R, spectator ions. Okay, so these spectator ions are the ones that do not show change in state. All those ions that do not show the change in state. Change in state. Okay, so which ones are those? So we see that sodium is aqueous on this side, and sodium is also aqueous on this side, and 2 of the sodiums. So those are spectator ions. Okay, next is the so it's just the sodium ions only. Okay, so 2 of the sodium ions with +1 charge and aqueous, soluble in water. Okay, so last question is, which one is the net ionic equation? Now, net ionic equation, you write down all the species, all the ions that are showing the change of state. So ions, write the ions that show the change of state. Okay, and which ones are those? So in this case, we see that we have, so two chloride ions, one negative charge, aqueous, right, reacting with 2H2O, which did not ionize here, liquid, and this gives you OH ion, one negative, aqueous, plus hydrogen gas, H2 as a gas, plus Cl2 as a gas. Okay, so two OH ions and the two H2O and two chloride ions. So these are the ones that are showing the change of state. As you can see, two chloride ions convert to Cl2, right? And if you see that H2O, which is a liquid, has broken into hydrogen as a gas and OH ion. So that again is like they are splitting up and changing the phase. Okay, so that's the net ionic equation for this. So let's look at the next problem, 4.3. Now the 4.3 is relating to the prediction of the precipitation reactions. 4.3, and this is, let me write this down, learning check. Learning check 4.3, page 185. What solution could we use to precipitate the barium ion in water sample? So we want to precipitate barium ions. Barium is barium +2 in water. Water means aqueous, AQUEOUS, aqueous medium. Okay, in a water sample. So you have, in other words, barium ions reacting with barium ions, Ba+2, aqueous, reacting with NaCl, okay, reacting with sodium hydroxide, NaOH, and also reacting with sodium sulfate, Na2SO4. Okay, what is the formula for the expected precipitate? So in other words, barium is going to combine with the non-metal side. So could combine with chlorine, could combine with OH, and can combine with the sulfate. So what are the three things that are formed here? The things that are formed is BaCl2. Here you have BaOH whole twice, and you have BaSO4. BaSO4. So this is aqueous, and this is solid. Now, how do I know what is this? I mean, you can always make, you know, this part is easy, where you have a metal and it connects with the non-metals, right? And you have a species like barium chloride, barium hydroxide, and barium sulfate. But which one is a precipitate? Precipitate is the one that is that is going to, so we are trying to find which one is a precipitate. Precipitate, and I'm putting it as PPT. Okay, so we see that now. You will consult or remember the solubility rules. Okay, so according to the solubility rules, if you look at the solubility rules here, in the solubility rules, we see the chlorides, all chlorides, halides is all chlorides. All chlorides are soluble in water except silver chloride and PbCl2. Okay, so BaCl2 is going to be soluble in water. So with that said, you are going to write this guy as BaCl2 is soluble. So that is why aqueous. Okay, next is barium hydroxide. Now, all hydroxides are insoluble in water. Insoluble in water means that they are going to form a solid, except group 1A, ammonium, and barium hydroxide. So we see barium hydroxide is soluble in water. So therefore, you are going to place AQ, sorry, you're going to place AQ over here, aqueous. Okay, next is BaSO4. Now BaSO4, I already put solid. Why? Because right here, according to the rules, because they're memorized, right? So sulfate, all sulfates are soluble in water except barium sulfate, strontium sulfate, calcium strontium, lead, and silver sulfate. So barium sulfate falls in that exceptional category. And so this guy, barium sulfate, is insoluble in water. That is why this is BPT. Okay, insoluble in water. So these two are soluble in water. Okay, so that's one thing. Okay, let's look at the next problem, which is 4.4, and it relates to the net ionic reaction, for a neutralization reaction. Okay, let me write this problem. Okay, so here they're saying that in a learning check 4.4 on page 189, it relates to the acid-base reactions. Now, acid-base reactions are also called the neutralization reactions. Okay, whenever the acid and the base, they react, they produce salt and water. Now, salt is not all the time NaCl. Any of the ionic compounds, they are also like broadly termed as salt. So now they're saying that for any, so remember that in general, the net ionic equation for all the neutralization reaction is the same, because here you are producing water and the water is always going to be liquid. Okay, so that's one thing. Okay, so let's do. So they're saying, right, strong acid reacting with any strong acid reacting with an ionic hydroxide. Now, strong acids like, for example, H2SO4, okay? And ionic hydroxide, for example, let's do aluminum, AlOH whole thrice, okay? So when these two react, they are going to produce salt and water. Now, how is the salt formed? Remember, outer, outer, inner, inner. So this is outer, and then this is outer. These two will react, and that's how the water is formed. And inner, inner. So the inner is sulfate is going to connect with aluminum. Okay. So very important here, you need to memorize or know the charges. Okay, so you should know what would be the charge on aluminum, what's the charge on sulfate, and if it is not this is a sulfuric acid. Okay, and aluminum hydroxide. I just took a little bit of a difficult one, but in general, like nitric acid, sulfuric nitric acid, or hydrochloric acid, hydrobromic acid, those things, those names you need to know. So remember remember to go back and forth on the nomenclature if you are like, if you've forgotten those. Okay, anyway, so here we have first thing, aluminum and sulfate. Aluminum will have +3 charge, and sulfate has -2 charge. So when they crisscross, they form Al2SO4 whole thrice. Okay, so that's the let me write down a little bit more. So this is Al2SO4 whole thrice. Okay, crisscross. So refer to the nomenclature for that one. And I have a video made on that. So here, so sulfuric acid is aqueous. Aluminum hydroxide is aqueous. Okay, that is aqueous. Maybe not, because all hydroxides are insoluble except group 1A. So let's do this thing. Instead of aluminum, let's do ammonium hydroxide. Anyway, so ammonium hydroxide is NH4OH, ammonium hydroxide. Okay, and this is giving you, it's the same thing. The hydrogen is going to connect with H2O, with OH, so that gives you that. But ammonium and sulfate are going to react. And so then what is this being? So ammonium hydroxide is soluble in water. So this would be aqueous. And you have now ammonium and sulfate combining together. So ammonium has +1 charge, but sulfate has -2 charge. So this is the formula. And this is a salt. And that is obviously water. Okay. Now water water will not ionize. So sorry about that. Okay, so here we have AQ. So this is liquid. Okay, and this is aqueous because ammonium, all sulfates are soluble in water. Ammonium is also soluble in water. So if it's soluble in water, that means it is going to ionize. Okay, now we have to ionize this. So first balance also. So we have 2 ammoniums on the right hand side. So you put 2 here. This applies to ammonium and this applies to OH. Okay. And there are 1 sulfate. So 2 ammoniums. And what about the, so there are now a total of 2 and 2, 4. So we put 2 here. So that makes 4 hydrogens. So, sorry, leave the ammonium. So 2 hydrogens and 2 oxygens, 2 oxygens and 4 hydrogens. Okay, so that's balanced. Okay, now let's do the ionizing. This is going to ionize H2SO4, is going to 2 hydrogen ions +1 charge, aqueous, plus 1 sulfate ion, -2 charge, aqueous, okay, plus 2 NH4 plus 1 charge, aqueous, plus 2 OH -1 charge, aqueous, and this gives you 2 NH4 plus 1 charge, aqueous, plus sulfate SO4 -2 charge, aqueous, plus 2 H2O. Okay, so here we have, in this case, hydrogen, 2 hydrogens, 2 OH, and 2 H2O. Okay, and then you also see sulfate and sulfate aqueous on both the side, 2 ammoniums and 2 ammoniums aqueous on both the side. So which are the spectator ions? The spectator ions are 2 NH4 plus 1 aqueous and 1 sulfate SO4 -2 aqueous. Okay, so these are the ones that are the same on both the sides. No change in state can be seen. But the net ionic equation, the question is asking for the net ionic equation. Now here's the interesting piece. Anytime acids and bases are combining, the net ionic equation is always going to be the number of hydrogen ions that are on one side, which is in this case 2 hydrogen ions aqueous plus 2 OH ions -1 aqueous, and that gives you the 2 H2O liquid. Okay, so ideally, because these don't exist, this is the Arrhenius view. Arrhenius, Arrhenius said, oh, hydrogen ions, so that's why. But the Bronsted-Lowry said no, they are going to be the hydronium ions. So in other words, water is going to combine with these guys. So what happens now? 4 hydrogens, 2 oxygens. Okay, so this becomes hydrogen ions are going to combine with water. Okay, and with that said, we would have a hydronium ion H3O plus 1 charge. Okay, but then you can reduce this whole thing, make it simplified version, which is the hydronium ion H3O plus 1 charge aqueous reacting with the OH ions -1 charge aqueous, and that gives you the water is already there. So H2O was there. Plus 1 more H2O plus 2 H2O. Yeah, so 2 H2O. And that's the liquid. So, okay. All right. Okay, so we are going to end here. Next video, we are going to do the learning check on the redox reactions and the half cell method. Okay, but for now, we covered all the learning check problems from section 1.1 and 1.4. Thank you. I hope it was easy. Bye-bye.